All right, here we go, ladies and gentlemen. I'm going to share with you the Alex questions on type 1, type 2 error. And let's have a little quick conversation on the verbiage so you feel comfortable. So the first thing we would do here is consider that we're trying to determine whether or not the null hypothesis is true or not. What I want you to also remember is that if you have a true hypothesis and you reject it, you are making a type 1 error, okay? So in this question, it's saying executives of a supermarket chain are interested in the amount of time that customers spend in the stores during the shopping trip. The mean time, mu, spent by customers at the supermarket has been reported to be 36 minutes. But executives have good reason to believe that mu is actually greater than 36 minutes. The executives hire a consultant, so they perform the test statistics. The consultant collects a random sample and finds that the average is 41 minutes with a standard deviation of 41 minutes and a standard deviation of 12 minutes. So what they're asking for here is the hypothesis. So first of all, based on our question, we would say that mu is either equal to 36 minutes, or mu is not equal to 36 minutes. They said here very clearly, executives have reason to believe that the mu is greater than. So mu is greater than 36 minutes would be your alternative hypothesis. Okay, so suppose that the consultant decides not to reject the null hypothesis. What error might she be making? So if in this case, again, you decide not to reject the null, the question is the null a true null or not? So they're not going to reject the null. Let's go with type 1. And suppose that the shopping time spent by customers at the supermarket is 36 minutes. So a type 1 error would be rejecting the hypothesis that mu is equal to 36 minutes, when in fact mu is equal to 36 minutes. So these questions are a little tricky. I'm going to read it again, make sure I didn't make a mistake. So the idea is type 1 is rejecting a true null hypothesis. So let's take a look just to be sure at the explanation, because this would help both of us in the sense of understanding the gist of the question. So as I said, look at this chart right here, where you're going to focus that the null hypothesis, the null is actually true, and you reject it. So that's that first square right there where it says you made a type 1 error. If the null is false and you fail to reject the null, that's like believing a lie, and that's a type 2. So first of all, we are correct in this part where we say that the mu should be equal to 36 versus the alternative hypothesis where the mu is greater than 36, because very specifically they said that greater than was our value. So in this case, this is where we stated a type of error that can occur if the null hypothesis is not rejected. So the way they're stating this, when the null hypothesis is not rejected, only one type of error can occur: failing to reject the null hypothesis, which should have been rejected. And in that case, to reject the null hypothesis when it is false, therefore you might be making a type 2 error. type 1 error in this case would be, in this case, where mu is equal to 36. If the true mean shopping time is 36 minutes, we have a type 1 error, which is rejecting the null hypothesis that mu is actually equal to 36, when in fact mu is equal to 36. So I think we're okay with that. Let's see here. I'm going to return to the question. And let's do this again. So we have the null hypothesis according to the question is that mu is equal to 36. And the reason why right here, believe that mu, the executives believe that mu is greater than 36. That's why this part here will be mu is greater than 36. Okay, one more time. So suppose that the consultant decides not to reject the null. What sort of error could the consultant be making? In this case, it was type 2. In this case, we were good here where this is failing to reject. Well, no, actually this would be rejecting the null hypothesis that this is actually equal to 36, when in fact it is equal to 36. So again, type 1 error is the possibility that you would reject a true null hypothesis. Let's check. All right, so I think we're good there. Let's do one more or two more. Let's try, at least try a new one. Okay, so let's take a look at this one. This one says a consumer advocacy group is doing a large study on car rental practices. Among other things, the consumer group would like to do a statistical test regarding the mean monthly mileage mu of cars rented in the US this year. The consumer group has good reason to believe that the mean monthly average of cars rented in the US this year is less than the year's mean of 2,850 miles. So we begin with the fact that mu is equal to 2,850 miles. And according to this, we're going to go with the year that mu is less than that mileage. So 2,850. Suppose that the group decides not to reject the null hypothesis. What sort of error might they be making? Now, keep in mind, I said the type 1 is rejecting. So not to reject it would be a type 2. Suppose that the true mean monthly mileage of cars rented in the US is 2,850. What a type 1 error would be, let's see, rejecting the hypothesis that mu is equal to 2,850, when in fact mu is 2,850, equal to 2,850. All right, let's check that one out. All right, we're good on that. Once again, here's the explanation. I'll show it to you. You can read it step by step. Just to explain it, just as we did. So again, type 1 is rejecting a true null. Failing to reject is when we deal with a type 2. All right, so that's that. And try example 2 is probably more of the same, but just in case, let's take a look at it. Okay, same type 1, type 2 error type question. So this one is saying a researcher studying stress is interested in the blood pressure measurements of the chief executive officers, CEOs of the major company corporations. He has good reason to believe that the mean systolic blood pressure mu is less than 134. Okay, so he plans to perform a statistical test. He measures the systolic blood pressure of a random sample and finds that the mean is actually 128 and the standard deviation is 18. So the question is, what are the null hypothesis versus the alternative? So mu, I'm going to say mu is equal to 134. And according to this, they believe that it's less than, so we're going to say that mu is less than 134. Suppose that the researcher decides not to reject the null hypothesis. What sort of error might the person be making? So not to reject, type 2. Remember, reject is type 1. Suppose the true mean systolic blood pressure of CEOs of major corporations is actually 124. Okay, what is a type 2 error? So type 2 is failing to reject that the mu is less than 134, when in fact the mu is, nope, less than 134. Okay, this was a little tricky, so let's take a look at the explanation, see where we're at. One more time. So this is the original question, so you can pause the video if you need to. And as we continue, you can see the explanation one more time of what type 1 versus type 2 is. According to the question, our mu is equal to 134. And in this case, the alternative hypothesis is that mu is less than 134. This would be a type 1 error, if you notice carefully, for part B. And these are the responses. So type 2 error would be to fail to reject the null hypothesis that the mu is equal to 134, when in fact the mu is less than 134. Let's return to the question. We'll go back. So one more time, as we read the same question again, you would say mu is equal to 134. And here's the alternative, where you would say that mu is less than 134. Suppose that the researcher decides not to reject the null hypothesis, so they were making a type 2 error, because they're not rejecting. Remember, again, once again, type 1. In type 1, you are rejecting a true null. In type 2, you're failing to reject. So the third part, or part C in this case, would be that a type 2 error would be failing to reject the null hypothesis is equal to 134, when in fact it is actually less than 134. And there you go. All right, let's do another one. Let's take a moment and just read the question in. In this case, it says a coin-operated coffee machine made by big corporation was assigned to discharge a mean of 7.1 ounces of coffee. It says the company has good reason to believe that the mean amount of coffee dispensed is less than 7.1. So we're looking at mu is equal to 7.1, as opposed to mu is less than 7.1. So suppose that the company does not reject the hypothesis. So they could be making a type 2 error. And suppose that the true mean of coffee dispensed by the machine is actually 6.5. It says, let's fill in the error. It says a type 2 error could be failing to reject the hypothesis that mu is equal to 7.1, when in fact mu is less than 7.1. Okay. So let's check out what we have here. All right, so you can pause the video as you need and let me know if anything doesn't make sense to you. Okay, this next question deals with the type determining the null and alternative hypothesis. So be careful because this is on test 1. The records of a casualty insurance company show in the past its clients have had a mean of 1.7 accidents per day with a variance of 0.0025. The actuaries of the company claim that the variance of the number of incidents per day is no longer equal to that 0.0025. And so they want to know what the actual focus of the hypothesis is. So variance, basically we need this symbol, and we need sigma squared. Okay, and this value should be, in this case, equal to 0.0025. Okay, do the alternative. Once again, we have variance squared, or standard deviation squared is variance. And according to this is no longer, so they're just saying not equal to. So you skip out. Not equal to 0.0025. So be careful with the notation on these because it is tricky. Let's try another one. Or let me actually show you the explanation. So, well, that was quick. That is the explanation. They basically are asking you to remind yourself of the notation. Remember, lowercase sigma is just the lowercase sigma, versus lowercase sigma squared is the variance. Okay. Let's try another one. Okay, so last year's mean hourly wage in hours, or actually in dollars, for a hospital clerical workers in a large state was 8.5. That's an average. The administrator of the state believes this year's mean hourly wage for the hospital clerical workers is greater than last year's. Okay. So basically, we're going to simply say mean is equal to 8.5. And in this case, because they're saying it's greater than, the mean is greater than 8.5. That's all they're asking. Let's check our answer. There you go. And once again, here's the explanation in case you need it. It'll help you to see it, read it. Let's pause the video. Okay. Let's take a look at another example. Okay, a recent study at a university showed that the proportion of students who commute more than 15 miles to school is 15%. Suppose that we have good reason to suspect that the proportion is greater than 15%. So we're going to start with, in this case, with P is equal to 15%, or you can actually say 0.15, as opposed to, in this case, it's greater than. P is greater than 0.15. That's what they want, or how they want it expressed. Let's do another one of these. You have to read these questions carefully because there are so many little details. The records of a casualty insurance company showed that in the past, its clients have had a mean of 1.9 auto accidents per day and a standard deviation of 0.05. The actuaries of the company claim that the standard deviation, notice that they're using the actual standard deviation, not the variance, of the number of accidents is no longer 0.05. Okay, so they're simply saying in this case, because they're saying a sample, no, they're not saying a sample actually. So let's go with sigma is equal to 0.05, and the alternative is sigma is not equal to 0.05. And let's check. Okay, just take a moment. You can pause the video. If you need to see the explanation, here it is. And I'll leave it there for a minute. You can take a look at it. And let's take a look at another example. All right. Let's take a look at this. We're still determining the null and alternative hypothesis. It says last year's mean hourly wage in dollars in the hospital was 8.25. The administrator believes that this is increased because it's greater than. So if you notice here, right? So they're talking about mean, and they said it right here. So we know we're dealing with mu. So we're going to say mu is equal to 8.25. And the alternative hypothesis is that mu is greater than. So we're going to go greater than 8.25. There you go. All right. So again, here's the explanation in case you need it. You can just pause it and just look at it for a little bit. And they also make a good point, which I've stated before, but you probably forgot. The null hypothesis always contains the condition of equality, always. Keep that in mind. All right, let's take a look at the next type of example, which is a hypothesis test for a population mean, a z-test. Okay, and we'll do this step by step. And be patient with yourself. And I'll show you this in both Excel and on paper. All right. The claim. The word claim is very powerful in our stats class. So the manufacturer claims that the mean lifetime mu of its light bulbs is 54 months. The standard deviation is 6 months. Okay, we know that as fact. That's mu, and that's your standard deviation. You also now know that you have 100 bulbs, which means N is equal to 100. And their mean lifetime is 55 months. That's X bar. Can we conclude at the 0.01 level of significance that the lifetime of light bulbs made by this manufacturer differs from 54 months? Okay, pay attention to this word. This word always comes with this symbol right here where I'm pointing to, not equal to. So we're going to start with the null hypothesis, where we're going to say that that mean is equal to 54, and that alternative hypothesis mu is not equal to 54. Determine the type of test statistic used. Okay, to answer that, just come up here. There it is. It's a z-test. Now, to find the value of the test statistic, I'm going to talk you through the notes. And I should be sharing my screen. So we're going to go with, in this case, a z-score formula. The z-score formula is going to be equal to the sample mean minus mu over sigma. So, and I'll do it in Excel as well, so you can have both. So in our case, they found the mean of the sample size. Oh, by the way, this is over square root of n, my bad, my mistake. So you'll need this formula right here. So this z-score is equal to 55, which is a sample mean, minus 54, which is given to us as the mean of the actual population. We have 6 as the standard deviation, because they say the standard deviation is 6 months, divided by the square root of 100. Okay, so 55 minus 54 is obviously 1, divided by 6 divided by 10, which is 0.6. All right. So let's do this in Excel. I'll show you both so you can see both. And so I'm going to try and find you a calculator as well, so you can use that as a tool. But you know, first we're going to do this a long way. So we're going to start with, let's do sample mean. Let's do population mean, because that's given to us. All of that is going to get divided by the standard deviation. And that's going to get divided by sample size. Well, actually, the square root of sample size. And I'll give you a calculator as well, so you can use that. Okay, so our sample mean, I'm going to put here, a sample mean was 55. Our population mean was 54. Our standard deviation given was 6. And this would be the sample size, which was 100, of which we would take the square root of. So let me change that just to sample size. So what we're going to do is over here, we're going to compute this. So this is equal to, parentheses, sample mean minus population mean divided by sample size divided by the square root of this sample size. Okay, so that's correct. That's 1.016. Now that's a z-score. So now in that case, that goes there. This would be your answer, 0.016 repeating. I'm gonna leave it at 67. Now you want the p-value. So what you're gonna do then is the p-value is going to be at least, let's see, so we're gonna go with equals norm as dist. And that would be norm as dist, not norm. Norm as dist, and we want to click on this value. Let's see what happened. I did log mistake. Norm as dist. And that's the value we want. And so this is the p-value. This is the area behind. This is the area behind this number. So we're going to go with 0.5066. Is that okay with you? 0.5066. All right, I'll leave it at that. And then lastly, can we conclude that the mean lifetime of light bulbs made by this manufacturer differs? Does it differ? The rule of thumb is, because our alpha value, what is our alpha value giving? Oh, we're performing a two-tailed test as well. Let's see, get this up real quick. Since we're using a 0.01 level of significance, P less than alpha, reject a null. P greater than alpha, fail to reject a null. If I fail to reject the null, which is in this case, let me write that down for you here so you see it as I talk about it. Let me go to draw. So the rule of thumb is P is less than alpha. We're going to reject the null. Alpha for us is 0.01. That's stated in the question. Our p-value is 0.5066. Since that is not, notice that I'm saying not, we're going to fail to reject a null. If I fail to reject a null, the null hypothesis is that mu is equal to 54. The claim here is that it differs, so I would say no. Can we conclude no? Okay. Let's look at those numbers. Let's look at the explanation, see what they say. So I think we're on the many. So yes, mu is equal to 54 or not equal to 54. This is the formula we obtained, or the values we obtained. I did a one tail, so that's where this is going to differ a little bit. And yes, our final answer is no. So these are the values we should have. I think we were good. Let me return to the question. Let's try another question. Let's do that one. Okay, let's try this one together. So this one says an automobile assembly line operation has a scheduled mean completion time mu of 13 minutes. The standard deviation of completion times is 1.6. It says it is claimed that under new management, the mean completion time has decreased. To test the claim, a random sample of 100 completion times under new management was taken. They found a sample mean of 12.4 minutes. Can we support at the 0.01 level of significance that the claim that the mean completion time has decreased under new management? It says, assume that the standard deviation of completion times has not changed. We only want a one-tailed test here. So if you remember, I showed you how to do this on this little template. So let's talk about the template. Let's talk about using it. And you can recreate this. You don't need me to send you this, I hope. I will send it to you if you need it. So let's play. Okay, so according to this, this is what I have. Let me open this up just a little bit. Okay, so they're saying that the sample mean versus this value. So this is 13 minutes. This was given to us. Standard deviation of 1.6 minutes. I'm just reading off the screen. They're doing a sample of 60 versus 100. Once they did this, they also stated that they have a mean. Mean of 12.4 minutes. So this should be 12.4. Okay, notice that we have everything we need here. And we're also going to look at this as a one-tail test, which is what I did initially with the previous question. So, okay, so first things first, we're going to start with mu is equal to 30 minutes. So mu is equal to 30 minutes versus mu. They're saying they think it's decreased, right? So mu is less than, should be less than 13 minutes. Again, this is what you need, z-test. The value of the test statistic is your z-score right here in yellow. So this would be negative 0.048. And the p-value, according to this, should be 0.48. And you find that here. We could round that to 406 if you want, a 4.4806. Now, given this information, let's see what we do have. We know that the mu is for 13. The standard deviation is 1.6. The X bar is 12.4. And the sample size is 60. And they're saying that this is less than. And see what we get. So P less than alpha, we're going to reject a null. If I reject a null that I'm here, that means that this is decreased. So I'm going to go with the yes on this. A z-score seems a little off. It seems like it should be like negative 2.9. Let me check my numbers. I don't know why I did it wrong in the calculator. No, this number's wrong. There should be something wrong with this. Square root of 60. No, there's something wrong with this. This is not timed, that's why. That makes sense. Yeah, there you go. So this should actually be a different value. So should the p-value. This p-value should be very tiny. It's 0.0018 and change. And this number here is actually negative 2.904. Okay. And I still agree with this because of the p-value being so small. So let's check it that we're correct. We can also do a few things here that I want to now introduce. So first of all, here's the explanation in case you want to just look at it. You can pause the video as you need. And that's exactly what the formula on Excel is doing. Yes, this is 0.002, but that's rounded, so I used the full number. Okay, all right, now what I want to do for you is introduce you to a few calculators, because you know I love my online calculators. We simply need a z-test calculator. And I'm going to choose a really good one for you. I want you to use this. Omni calculator, statology, both of these are good. I'm going to go with this one, statology, just because. And yes, we're going to enter summary data. Okay. So once again, in our question, we have X bar, our sample mean, which is 12.4. Our sample size in this case is 60. The standard deviation, 1.6. And the mean that's given to us is 13. Calculate. There you go. This is exactly what we just got. It even gives you the value of the two-tail versus the one-tail, which is really good. So I'm going to share this link with you as well when I upload the video. I hope it will be very helpful to you, because you can use this for all of the questions as well. You even have the ability to do raw data. So if you did raw data, it would compute it for you. So that's pretty cool. Pretty good tool, pretty nifty tool. All right, where are we? I'm in Alex, here we go. All right. Let's do this example. Same type of question. And so let's, again, we can use Excel, you can use your, whatever you choose. If you want to use your calculator, I haven't used the calculator yet, but we're going to do that too. So this is saying that the breaking strengths of cables produced by a certain manufacturer have a mean mu of 1950, standard deviation of 100. It is claimed that an improvement in a manufacturing process has increased the mean breaking strength. To evaluate this claim, 43 newly manufactured cables are randomly chosen and tested. Their mean breaking strength is 1988 pounds. Assume the population is normally distributed. By the way, this is also another important statement. Normally distributed. Can we support with an alpha of 0.05 significance that the claim mean break time is increased? So they're saying that mu is equal to 1,950 versus mu is now greater than 1,950. Again, this is a z-test, that's no magic. You want to now compute this. Let's go ahead and use this calculator this time, just so you can see it all. You can use your online. I actually do it both ways, and we could do it on Excel as well. So let's do Excel first, since we've already used Excel. In Excel, we're going to put in our data. So the sample mean is 1988. The population mean, which is given to us, is 1950. The standard deviation, according to this, is 100 pounds. Sample size of 43. Okay, and there's your z-score. So you should have 2.49, and your p-value should be 0.99. So I'm going to go ahead and I'm going to try this on my calculator first as well. Just being a little paranoid. 1950, standard deviation 100, X bar of 1988, sample size of 43, and we want greater than according to this. Okay, I'm getting, drum roll please. I'm getting 2.49, exactly that, 2.49 with a very tiny p-value of 0.0064. So I see why this is so large. Yep, there you go. So this is greater than, that's why. So let me remind you of that. Even I forget that from time to time. This is always less than or the expected value or proportion based on location. Because the way that's labeled, this is the greater than symbol. So this one is when we have this symbol. If I have a greater than symbol. So I have mu is greater than that, 1950. That's when you use 1 minus the value you get here. So this number is 1 minus 0.993646. Okay. So according to this, yes, we can, because we have an alpha of 0.05. So that would be our response. So again, this was 2.4918, if you want to go all the way. And this gives you 0.0064 is one-tailed, so you only need to worry about that. Okay, so that's that. Let's do this on the calculator. So I would say parentheses. 1988, because it's the mean minus the original mu divided by, again, parentheses, I would do the 100 divided by the square root of our sample size, which is 43. And that gives us our z-score, 2.49. Now, if you want the p-value of this, let's go ahead and play with this. See how you get 0.99, and in this case, because it's greater than, you go 1 minus that. And there's your answer, 0.0064. You just have to round it yourself. So that's on that mechanism. Let's do this on the calculator that I showed you just now. Again, we're going to enter data summary. So you want the sample mean, which we said was 1988. Sample size, which we said was 43. Standard deviation was 100. And our mu, what was our mu? Forget, 1950? 1950. Okay. And there's your answer. There's everything you need. Okay, so that's a couple of resources shown several ways. You want to see the formula? I can do the formula for you too. We can do that. Let's take a look at that the long way. So looking at the formula, we're going to say Z is equal to 1988 minus 1950, because remember it's X bar minus mu divided by the standard deviation, and that's divided by the square root 43. When you throw that into the calculator, as I showed you, you get your 2.4918. And then what I did in Excel was I said equals norm as dist, and you put in the 2.4918. Sorry, it just glitched on me. But 1.1498, you're going to get the opposite. So you do 1 minus 0.99 and change, and then that is going to end up giving you the 0.0064. Okay, so that's just showing you various ways of approaching the same question. All right, let me see if I can narrow this down. Let's pare this down again, and let's take a look at proportions. These questions are very easy, just they can be confusing if you don't write down what they're referring to. Okay, so we're going to start with the antidepressant. So according to the question, it says an antidepressant has historically been known to relieve depression for 65% of the patients, which means that there's 35% that are not getting relief. Keep that in mind. So always think about that. So it's saying the drug's formula has changed recently to include a smaller dose of an active ingredient. Due to this change, the medical researcher suspects that all people with depression who use the new version of the drug find relief is lower than 65%. A random sample of 220 patients who used the new version is selected by a researcher and found that 123 found relief from depression. Based on the data, can we support the researcher's claim at the 0.05 level of significance? Obviously, we're also doing a one-tailed test. So we're going to start with the hypothesis. This is very simple, which says that P is equal to 0.65. And the alternative is that P is less than, because they said less than 0.65. It's always going to be a Z statistic. We're not doing anything else yet. They want us to actually do the P test. This is a one prop Z test, by the way. So you notice that they give you the 0.65. So 0.65 is our initial value with P hat, which is 123 X over 220 N. And then it says, in this case, we're trying to find out if it's lower or not. So let's take a look at our result. It should be negative 2.827 with a very small p-value. Let's take a look at the explanation. Let's see what they say. And pay attention to the notes so you can see. So that's given to you. So 0.65. Remember I mentioned 0.35? So look at the explanation. And it is negative 2.827, like I said. Just take a minute. Take your notes if you need to. Just write it down. You're then also going to use the P of Z, which we can talk about the formula. What you're going to get, like I said, 0.023, very small formula. And then lastly, you're going to determine whether or not it's significant, which obviously it is. So let's go back to this formula here. This is where I really need you to take notes and be very clear on understanding what that symbolizes. All right. All right. With that said, let's also go back out into the internet. And let's look for another interesting calculator. This is called the one prop z-test calculator. And I'm not going to use Math Cracker. I'm going to use Tautology again. I like that website. I think it's great. So I want you to notice that our sample size, the observer proportion, and the p-value. So our p-value was 0.685. Our sample size was 220. Now here's the issue. I need this to be 123 over 220 as a decimal. So let's find out what that is. I'm going to go to Mode Clear. I'm going to go to my calculator. 123 divided by 220. I'm getting 0.559. Let's calculate that. And that is very close to what I got. I'm not too thrilled with the fact that we're slightly off on decimals, and that might become an issue for you. But I can set up the calculator for you. We could do that instead. This is where Excel is your best buddy. So let me go down here to this part here, and I'm going to call this one proportion z-test. Okay. So I'm going to call this the p-value. Oh my goodness. And over here, I'm going to put X and N. This is called the p-hat, which if you look at the symbols, I'm talking about this little guy with the little hat. That's why p-hat. This is usually just p sub 0 technically. So in our case, we know that this value is 0.65. This value for us is 123, and this value is 220. So p-hat itself, I'm going to call it p-hat so you can see what I'm talking about. This p-hat is equal to the 123 divided by 220. See how you get 0.559? Okay. So let's set up the formula. I'm going to set it up for you, and we'll do it together so you can see the big picture. This is always going to equal, the z-score is equal to this number minus this number for the top part. And that's just the numerator. This next number is equal to the square root. I'm going to do double parentheses of this number times parentheses 1 minus this number again, close parentheses, divided by n, which is always a 220. Close parentheses, twice? No, not twice, just once. I was trying to close parentheses and give you very strange number. Okay, and now if I take this number up here and divide it by this number down here, I get my answer. So this number at the bottom is your z-score. Right here. So let me just highlight this as your z-score. The numbers you will change are just these. Everything else do not touch. No touch. All right. So let me make them a little bolder, and I'll make the color a little lighter. And that'll be helpful to you. Send to them and make them bold. There you go. Yes. All right. So only change these. So. All right. And this is your Z-score. We need that. Now, same thing applies here, equals norm as dist. I'm going to click on that number. And if it's less than or just asking a regular p-value, that's the answer. And if it's greater than, then we're going to simply do 1 minus equals 1 minus that number. And that's the other side. Okay. Okay. And I'm going to go call this file, save as this PC, desktop. I'm going to call it WU week 7. And that should help you quite a bit, I think. All right. Now let's do this back to this question. So we did get our numbers correctly. Awesome. Let's go and return the question. And I'm actually going to just do another one. So you can try another one and we'll call it a day. This one is a two-tailed. By the way, when you do two-tailed, all you simply need to do is add or multiply the value you get for the lesser than and multiply it times 2. That's it. So according to this question, it says, a decade-old study found that the proportion P of high school seniors who believed getting rich was an important personal goal was 80%. A researcher decides to test whether or not the percentage still stands and finds that among 245, 213 believe that getting rich is an important goal. So I'll tell you what, I'm going to do this one first on Excel. Then we'll do it in the computer, and then we'll do it on the calculator. So you see it always. So this is a 1 proportion. So our number here is 0.8. According to this, 213 out of 245. So let me narrow this down so we're not competing on the space. So this X bar is a small number. This would be the 213. This number here would be the 245. But there's your answer, partially. The reason I say that is because you need to multiply this. Are they asking for greater than or less than? On a two-tailed test, yeah, so that this will be, we'll go to two-tailed, come over here. So it would be equals that times 2. This would be a two-tailed test. All right, so I'm going to go ahead and run it on my calculator just to check my answers. Because I never assume. So this would be 0.8. This would be 213 out of 245. Not equal to. And I'm going to draw it. And then I'll do it on, like I said, I'll do it on the, okay, so I'm getting the same answers. I'm getting 0.066, that's correct. I'm getting the 2.7, so we're good. All right, so yeah, my intuition was good. Let's go to the test, the actual calculator. So 0.8, our number is 245, so 245. And our value for 245 would be The original question here. That was. Wait 1 second. I'm trying to find our question. Here. It was 213. 0.869. Okay, so I'm gonna go with 0.869. All right. So I'm getting 2.7, and two-tailed I'm getting 0.006. So if you notice, this rounding is a little different from the Excel that I provided you. So just take a look here and you'll see why. Because the issue is, I think, is right here. See how if I do equals the 213 divided by the 245, you see how I'm getting 0.869, but there's a 388 following. I wonder if I could change that 388 in this calculator again. Well, that comes closer. I feel more confident with that. Much more confident with that. So yeah, type in whatever decimals come in. If they have longer decimals, put them all in. And I basically just put that in as a proportion. So that's the observed sample proportion. There you go. So you can use that as well. All right, super. Let's go back to the question. So we're here. So again, according to the question, we would say P is equal to 0.80. And we're doing two tails, so P is not equal to 0.8. As a z-test. The value of the test statistic is in yellow, 2.715. Since we're looking at 0.01, you want a critical value of 0.05 really, because it's two-tailed. So if alpha given to us, it's given to us as 0.01 for two-tailed alpha, we're going to go with equals that divided by 2, which is 0.05. So if I go equals norm S inverse, I want the absolute value of this number. So actually it's going to be 0.576. So let me clear that out for you so you don't have a problem. So that's the absolute value of that number. See, it's going to give you the positive. So this would be, you're going to put negative 2.576 or positive 2.576. And now the question becomes easy to answer, I think. Because now you can ask yourself, is P less than alpha? Given a two-tailed. And remember, that means the tail that you're looking at now is 0.006. And they're giving us an alpha of 0.01. So let's go with yes. And fingers crossed, let's check. Something empty. Oh, I forgot the P. There you go. There you go. All right, so there are your notes for this week. And I'm gonna send you this file, like I said. You should find it hopefully helpful. So I saved it as week 1. And that's everything you need to know. I will send you the links, the calculators, everything immediately with this. Awesome. Have a great week.